In this video, we are going to go ahead and learn how to solve quadratics using square roots. Before we do several of these examples, I wanted to just go back to like an Algebra 1 idea, probably even pre-algebra, and just solving equations. And this is 3 just in x here. We don't have squareds like in these examples that we'll be looking for. So 3x minus 7. And so when we solved these, we just wanted to get x by itself, and we would do inverse operations to get us there. And what I want to do is show you that a question like this is very similar to what we're going to be doing in today's lesson. There'll just be one more step or one more inverse that we have to think through. So as we look at this equation, 3x minus 7 equals 8, here is our x, and we want to solve for that. So the first thing we do is we add 7 to both sides. We add 7 because that's the inverse of subtracting 7. So we add 7 to both sides. That gives us 3x equals 15. And then now it's 3 times x equals 15. So how do we undo multiplication? Well, we divide both sides by 3. And we get x equals 5. And we're going to do that same idea with these other questions where we're trying to solve for x. It's just that when we have an x squared or something squared, sometimes we'll actually have like a x minus 5 squared, but in order to get rid of a squared, the inverse of squaring is to square root. So when we take the square root of both sides, we actually have to put plus or minus in our answer. So let me just make one up here. X squared equals 49. Now in our minds, we can think what squared equals 49 without doing algebra, and we know 7 squared equals 49. However, negative 7 times negative 7 also equals 49. So when we take the square root of both sides, which we're allowed to do, we actually put a little plus or minus here outside of our square root on the part that does not have the variable, and we get x equals plus or minus, and then the square root of 49 is 7, which means 7 is an answer and negative 7 is an answer. So the way that we read this is plus or minus. So I'm going to work through the even questions here. And number 2, we want to solve for x. Well, there's a squared there. So the first thing we're going to do is we're going to try to get to what we say, isolate the squared. And so how do we isolate the squared? Well, in this case, we can subtract both sides by 100. And we get x squared equals 36 over 100. There's a few things you can do here. I'm just going to leave it like this. And right now, we're going to take the square root of both sides to get rid of the squared. And when we take the square root of a fraction, it's simply equal to the square root of the top over the square root of the bottom. Now, I don't even always write this, but I just wanted you to know this concept because we could have thought through this in our heads. The square root of 36 is 6. So I should make sure we put plus or minus. So the square root of 36 is 6, and the square root of 100 is 10, and that actually reduces to plus or minus 3/5. And you could have even put the square root of, let's put a calculator up here just so you see this. You could have done 36 divided by 100, and we could have taken the square root of 0.36, and that's 0.6. We also see that 3 divided by 5, or 3/5, is 0.6. So anywhere along here, you can change it to decimals. There will be times where we just leave it as a fraction, but we can put plus or minus 0.6. All right, the next one here. we have x squared equals 9. Well, this is very simple because there's nothing to add or subtract or multiply to divide to start with. We can just do the square root of both sides. And remember, when we do the square root, we do a plus or minus next to the number part. And so a square root and a squared cancel, and we're just left with x. And then the square root of 9, so we still have plus or minus. The square root of 9 is 3. Number 6 is basically the same question. It's just n squared equals 36. There's nothing to add or subtract first, so we can take the square root of both sides, remembering to put plus or minus. On the left side, the square root and squared cancel, and we're left with n. On the right side, we have this plus or minus, and we think, what is the square root of 36? And the square root of 36 is 6. All right, number 8 looks a little more complicated, but again, it's still much like this Algebra 1 problem that we looked at to start with. Actually, it was just this part up here. So what we want to do is we want to isolate the b squared first. So we're going to get b squared by itself, and then once we do that, we can take the square root. So we're going to start by adding 1 to both sides. And we get 7b squared equals 217. And then we're going to divide both sides by 7. If you need to get out your calculators to divide 217 by 7, that is quite all right. Go ahead and do that. This one turns out to be not too bad because 7 goes into 21 3 times and into 7 once. So this is going to be 31. And now, unlike the previous questions, like number 4 and 6, we can go, we're going to take the square root of both sides, which is the same as 4 and 6. However, square root of 31 is not really a known value. It's not an integer. So we can put plus or minus. Technically, and we'll talk about this later, square root of 31 is a good answer. But we haven't talked about how to simplify radicals yet, so we can go ahead and bring out our calculator again, and we can do the square root of 31. And we'll go, that's about 5.58. Sorry, 5.57. Looking at the wrong thing there. So about 5.57. All right, number 10. These are going to be pretty simple again. I realize there's some more simple ones in here, but we'll go ahead and take the square root of both sides, making sure we put plus or minus, and we get x equals the plus or minus, and then the square root of 4 is just 2. Same concept for number 12. This one's a good one to look at because sometimes we forget that actually the square root of 1 is just 1. Good, we get to some ones that have a little more meat to them on the back. So for number 14, once again, we want to isolate this radical first, not the radical, the square root first. So we're going to subtract 3 from both sides. You get 25 n squared equals 9. Then we want to isolate the n squared, so we'll go ahead and divide both sides by 25. You can go ahead and do 9 divided by 25 on your calculator if you want to. I usually just leave it, especially since both of these are perfect squares, so 9 over 25. And now I would take the square root of both sides to get this n by itself, and I'll make sure to put plus or minus over here. So as mentioned before, when you do this, when you have a fraction, you can do the square root of the top. So the square root of 9 is 3. The square root of the bottom, the denominator, the square root of 25 is 5. So our answer is plus or minus 3/5. You could put that in decimal form if you wanted to. That's plus or minus 0.6. Moving on to 16. we need to divide both sides by 100 first. And we'll get n squared equals 64 over 100. We could reduce that because there's some numbers that go into both of those fours specifically. But I do notice that 64 and 100 are both perfect squares, so I'll just go ahead and take the square root of both sides. This is n equals, because the square root and squared cancel, plus or minus. Remember, when we do the square root of a fraction, we can do the square root of the numerator. Square root of 64 is 8 over the square root of the denominator. Square root of 100 is 10. However, I also notice we can reduce these by 2. So 2 goes into 8 4 times, and 2 goes into 10 5 times. So we have plus or minus 4/5. Again, we could change to a decimal. That 4 divided by 5 is 0.8. Again, we want to isolate the squared term. So we want to add 4 to both sides. So we get b squared is equal to 1. Now that's when we could think in our mind. We know that it's plus or minus 1, but we can follow the algebra rules and we can take the square root of both sides. The square root of b squared, the square root cancels with the squared, and we get b equals plus or minus, and what is the square root of 1? It is 1. All right, now our last two, these have a little bit more to them, but it's okay. And they're a little set up a little different. We haven't had something inside the squared before, but that is okay. We can work through that. That's what we're trying to learn today. So same concept holds true. I want to isolate the squared. So to do that, I'm going to add 6 to both sides. And I get this 2x minus 1 squared equals 4. Now, the temptation is to add 1 to both sides and then divide 2 to both sides. But really, the next thing that needs to be taken care of here is the squared, because everything's inside there. So we actually take the square root now, because we did get the squared by itself. It's that what's in parentheses squared. So we'll take the square root of both sides. And we get the square root cancels with the squared to leave us with 2x minus 1 equals plus or minus 2, because the square root of 4 is 2. This is the first time we've gotten to something like this, because we have a 2x minus 1 equals plus or minus 2. We actually have to split this up into 2 parts, and I wish we had more room right underneath it, but we'll just split it up here. We're going to split this up into 2 parts. We have either 2x minus 1 equals the positive 2, or the 2x minus 1 equals the negative 2, because of that plus or minus 2. So 2x minus 1 equals the positive 2, or 2x minus 1 equals negative 2. And then we solve these two little equations. We'll add 1 to both sides, and we get 2x equals 3. Divide both sides by 2. And we get x equals 3 halves. Or if you want to, you can write 1.5. And then over to our other equation, we must solve both of them. We get 2x equals negative 1. And we can divide both sides by 2. And we get x equals negative 1/2. So this time, what we should do is we should write x equals 1.5, and then you just put a comma, negative half. And then number 22 is going to be very much like that one. It actually has one extra step, but, well, not necessarily. We want to isolate this squared. Now, the 3, notice I tried not to get the 3 in my little box there. The 3 is not squared. Only the x plus 1 is squared. So how do we get that x plus 1 squared by itself? Well, first we subtract 5 from both sides, and we get 3 times x plus 1 squared equals 300. Now we need to get rid of that 3 that's multiplied by the x plus 1 squared. So we divide both sides by 3. And now we have isolated the squared, which means now we can take the square root of both sides. Make sure you put the plus or minus over here by the square root. On the left, the square root cancels with the squared, and we're left with x plus 1. Over on the right side, the square root of 100 is 10, so we have plus or minus 10. And we'll do the same thing as we did on number 20. We'll come over here, and we have 2 parts. So either x plus 1 equals positive 10, or x plus 1 equals negative 10. And we solve each of those little equations, which is pretty easy in this one. Subtract 1 from both sides, and one of our answers is 10 minus 1, which is 9. And then on the other equation, we subtract 1 from both sides, and we get x equals negative 11. And so remember what we can do is we can put x equals 9 comma negative 11. In fact, oftentimes they'll put the 2 answers in brackets. So hopefully going through those even questions helped you get a good understanding of how to work through those. You can obviously watch these examples again as you work through the even questions.